quantity 9k plus 2p, which is equal to 7 m z. That's actually a really good question. That's a tough one to be able to work with. Okay, so make sure you guys are all okay with those algebra steps, because I don't want to finish working this until you guys are telling me that the algebra looks okay with this. So anything up there that looks suspect algebraically, or anybody need any explanation of the algebra rules? Okay. John, does that make sense? Did I lose you anywhere when you were looking at those? Or did you get a look at it?
So you can put 7p in, replace.
Yeah, because what we did, John, was right here. Remember, with induction, you have to assume that this is true for all n equals k. So right here, we did that induction. So where we said, like somewhere back here, when we do the inductive hypothesis. So remember, you have to assume it true for all n equals k. And by definition of divisibility, if 9k minus 2 to the k is divisible by 7, then 7p equals that by your definition of divisibility. Okay? So this is just like where you say for all n equals k, it's true. Okay? So that's like in the step before that where you have to do all that stuff. Okay? So does that make sense, John, where that 7p comes from?
Yeah,
Okay.
because ahead of time you already know that 7, like if 7's on the left and the right is 7p, and then
You got it. That's exactly right. Yeah, you know that if it's divisible by 7, you can just, or if it's 15 or whatever it is, you can write whatever. Okay?
yeah.
Okay. All right, any other questions about that one? Yeah, that's a pretty tough one. I'm glad you asked me about that one. Okay. What other specific questions might you guys have about anything that you guys might need to know about what's on the exam, etc., or any specific problems you guys might want me to work? Christian, and then
on the exam review, number 4,
yeah.
specifically the second one.
Oh, the second number 4.
Well, both of them, but mainly the second one.
Oh, I got you. This animal right here.
Yeah.
Oh boy. Yeah, you really want to make me work. Thanks. That's okay. Yeah, this was one that using those rules of logical inference. So this is number 4b. Chris, do you mind if I do number 4b first, since that's the harder one, and then I can do letter A? All right. So for 4b, unfortunately, I'm going to have to copy this down. Sorry, guys. So just give me a second. So this is S or V, and then we have not or, and then we have not P and V implies T. By the way, this T is not tautology. That T is just variable T, not P or Q. Implies not S. P implies R. And then therefore T. All right. To be able to do this one, okay, I didn't necessarily say how to do this one, but because you have a whole bunch of variables in there, okay, my suggestion would be that you would use the rules of inference for this. Okay, so let me bring these back up just to remind you guys. Okay, so if you have more than 3 different types of variables, my suggestion would be start with the rules of inference. Because if you have 4 variables, okay, doesn't that mean you're going to have 16 rows? And what if you have 5 variables? That would mean you'd have 32 rows. And you guys don't want to deal with that. Okay, it's much, much easier to start using the rules of inference. Okay. You may or may not remember, guys, but I think I told you to start with the easiest possible premise and then see what links up with that. So to me, it looks like not R is going to be the place to start with, right, guys? Because it's the easiest thing we have. Okay. The only thing that has an R in it is P implies R. Okay. So to me, it looks like that we're going to be able to build some sort of statement or one of these basic rules of inference using what we have up here. Okay. So does somebody think they might be able to build a statement that can help us with a conclusion? Right.
Modest tolerance?
So you would say for step 1, P implies R. We already have not R, and by modus tollens, that would be not P, right guys? So take a look at your modus tollens, the second of these rules. You have one statement implies another. You don't have the other, that implies that you don't have the first of those. Okay? So the way that you might justify this is given, and then modus tollens. Okay? So that's your step 1. Remember guys, once you use them, okay, you can get rid of them. Okay? Doesn't mean you have to get rid of them, but you can. All right. So now that we have a new variable to work with, we have not P. Okay. I'm looking at what we have left. Okay. So we either have statement 1, statement 3, or statement 4, and the only one that really has not P is either statement 3 or 4. Okay. So which of those two can we realistically work with? Statement 3 or statement 4?
Statement 4.
It's actually going to be statement 4. Because remember, you can't assume an and. You can assume an or, but you can't assume an and. I think if you guys were to use generalization, okay, if you look at this guy right here, if you have a statement, then you have a statement or anything else you want. Okay, so here's what I might say. I might say that we have not P from step 1. Therefore, we have not P or anything else in the world that we want. Okay, we get a pink elephant, we get a bottle of 151, but for our purposes, what would be the most effective thing to have?
V.
Q.
Q, sorry, Q.
Because we have to have not P or Q.
Q.
Okay, so it could be anything at once. Okay, so this is by generalization. Now that we have that, then we can just go ahead and just say that we can get to not S from there. Okay? And we're pretty close to getting done with this. So let me just go ahead and finish that off. That's the only tricky part of the problem. So is that okay so far, Chris? Okay. Next thing we're going to do, we have not P or Q. We have not P or Q implies not S. So not P or Q. That's from step 2. Given to us, oh, I'm sorry. I dyslexiated that. So this is going to be not P or Q implies not S. We have not P or Q from step 2. This is given. So therefore,
Modus ponens, not
Yep.
S.
by modus ponens, we have not S. Good. Okay. We can cross this off. I'm not the smartest guy in the world, but it doesn't look like statement number 3 has any S's in it, but it looks like statement 1 has an S in it, so let's use statement 1. Okay. For step 4, we have S or V. We know that we have not S from step 3. This guy's given. So what can we say as a result?
V.
We have to have V, right, by elimination. Okay? So look at your elimination. Elimination says that you have one or the other. You know that you don't have one, so you have to have the other of those. Okay? So therefore, you would have V by elimination. Cross this off. We had not P from step 1. We had V from step 4. We're going to conjoin those together to get to not P or and V. Okay, so we have not P from 1, we have not, or we have V from 4, so therefore we have not P and V, and that's going to be from conjunction. And then finally, because we have that, we can get to the T that we need. Okay, so 6, we could say not P or V, or and V, excuse me, implies T. We have not P and V from step 5. Therefore, we have T. And that's by modus ponens again. And this guy's good. All right, so let me get out of your guys' way. I know you're trying to copy down. All right. Chris, were you just making sure I knew how to do that?
Yes.
Okay, I appreciate that. So, or it could just be lying all semester, one of the two, with some wizardry.
Can we also do this for 4A? You actually want us to construct like a truth table for one and this for the other?
Well, John, that's a good question, okay? My suggestion would be that whatever's easier, use that method, because I might not tell you which one to use. If there's 5 variables up here, you don't want to make a truth table, okay? That would be 32 rows, you don't want to deal with that headache. If it's something like the one that I'm going to work, that Mr. Andrews requested that I do, like this guy right here has 3 variables in it, just truth table it. Because quite honestly, you might not be able to use the rules of inference to be able to prove this because there's nothing simple to start with, okay? So that might be another way to think about it. If you can't start with like a single argument, you might have to use the table. Okay. So other questions about that one, guys? Okay, and Chris, you wanted me to work on 4A as well, sir? Okay, just to make sure I can do it. Doesn't hurt my feelings. I appreciate it, thanks. Because you know, teaching the 12 course for 12 years in a row hasn't made me rusty. But you guys have only seen it for 3 months. Okay, so this guy right here, 4A, I would use a truth table on that, just because it would be a lot easier to do so. I'm going to quickly generate a truth table. So P, and then we have Q, and then we have R. Okay, just to remind you guys. T, 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 F, 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 F. And then T, T, F, F. T, T, F, F. And then F, T, F, T, F, T, F, T. Okay. Obviously, I didn't line those up too well. Oops. Yeah. Oh, sorry. It's bothering me. Obsessive compulsive disorder. It's probably not going to look any better. But, oh well.
At least you think it looks better.
Yeah, as long as I think it looks better, that's all that matters, right? I think, therefore I am. What we're going to do, guys, is we're just going to fill out the first 3 of these, okay? I think Marvin told us earlier, as soon as you get to a false, don't even worry about that row anymore, right, guys? Because remember, that's not a critical row, okay? So for P or Q, it looks like that for P or Q, the first 6 rows are going to be true, but then at the end, since it's false for both of those will be false. So we're just going to cross these out. So this guy doesn't matter, and this guy doesn't matter, but the rest of these are true. Then we have P implies not Q, okay? Somebody remind me, I know it's been a long time, but when is implies false?
When the consequence is false.
When true implies false, right guys? That's what the other one around. That's okay. So remember, implies is false. If true implies false, that's the only time that a conditional statement is going to be false. All right? Now remember, this is P implies not Q. So wouldn't it be true that both P and Q would have to be true for that part to be false, right guys? Because that would be true implies not true, which would be false. Okay? So if they're both true, then the output from this would be false. Okay? So P implies not Q. Since they're both true, this is false, and we can cross out the rest. Since they're both true, this is false, we can cross out the rest. And then the rest of these are going to be good, I believe. Okay, true, 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 true. Okay. So now we're only down to half the work necessary because we've gotten rid of a few of those rows. The last one we have is P implies R. Okay. So for P implies R, for row 3, we have true implies true. That's good. Okay. So this row is critical. We have true implies false. So that's false, which means that row number 4 is not critical. And then for the rest of them, I think they're good, because this will be false implies true, false implies false. So those are both true. So out of all of that, it looks like that we had 3 critical rows. Okay, row 3, row 5, and then row 6. All right. We're looking at the conclusion. If you notice, the conclusion is R. So right here, this is all good. Right here, this is all good. And then when we get here, that's no good. We can't have a false conclusion in a critical row, so we wouldn't have known that until we did every single possible step for this problem. So for this one, unfortunately, it's not a valid argument for. Okay, so right here, not valid. Okay, so Christian, does that make sense? So, okay. All right, guys, any questions about something like number 4?
So you can still prove it not valid by using this, or do you have
No.
to use a truth table?
For that one, you have to use a truth table, because Greg, there's nowhere to even start
That's what I
on
was
this
thinking.
one.
I had no
Right.
idea. But,
It'd be really nice if you could, but unfortunately.
and because you can't start it, then you have to move on to this step
Correct.
to determine whether or not it
Yeah.
truly is invalid.
Correct, sir. Okay. All right, Brian, you had a question, I believe?
Yeah, do we have to do the mapping of the graphs, like from the,
Oh, the isomorphic thing, or
what we were doing last class where we had.
not on the final? No,
No, okay.
I didn't put the isomorphism on. All right,
I
Greg?
have a question from, I believe, the last exam.
Yeah,
Uh,
I might have an answer.
It says prove for all n that exist in an integer C, n is greater than or equal to 3, where 2 the permutation of n comma 3 minus 2 n permutation n comma 2 equals -4 permutation n comma 2.
Okay, so it was, one more time.
Right, for all n exists in Z, n is greater than or equal to 3. Okay, yeah, the 2p and then n3. And then minus 2np, n2.
Okay, and that's supposed to be equal to
Negative
negative 4p n comma 2?
Yes.
All right, hopefully. All right.
Yeah.
Yeah, this one's not an easy one either,
And
so,
my biggest issue was finding the correct common denominator.
as were a lot of people that
Yeah.
weren't able to do this one. Okay. So, basically what we're gonna do is we're gonna start by using the definition of permutation, okay? So this would be 2n fact divided by n minus 3 fact